Hello students, welcome to today's session of chemistry. As you all know, we have started studying fifth lesson of your syllabus, that is electrochemistry. Before starting today's session, as usual, we will just revise what we learned in the previous session. In the previous session, we started study of primary voltaic cell, and the example is dry cell, or we also call it Leclanche cell. Why it is called primary voltaic cell? The cell which cannot be recharged is called primary voltaic cell. That means a dry cell, after discharge or after usage, we have to throw it away because it cannot be recharged. Now, what we learned in the previous session? We learned about the construction of a dry cell. Shall we revise that? Okay. After revising, then we will proceed for cell reactions. Now, the construction of dry cell. The container of the cell is made up of zinc. That means the container, the vessel is made up of zinc and which serves as anode. Hence, the outermost vessel or the container is made up of zinc and which works as anode, that is negative. This container is lined from inside with a porous paper. It is called paper spacer. Why it is there? It separates the other material of the cell from the anode. There is an inert graphite rod at the center of the cell, which is immersed in the electrolyte paste, and this graphite rod serves as cathode, that is positively charged. The cathode or this graphite rod is immediately surrounded by a paste of manganese dioxide and carbon black, we can say. The rest of the cell, so this part, the rest of the cell is filled with a moist paste of ammonium chloride and zinc chloride, and this is electrolyte. In this paste, some starch is added so that the paste becomes somewhat thick and so that it cannot be leaked out. This total container is sealed at the top to prevent drying of the paste by evaporation of moisture, so that the paste remains moist only. Why it is to be moist? Because as we know, the redox reaction takes place in this cell, and redox reaction means transfer of electrons, and for transfer of electrons liquid medium is needed. But liquid medium, if we use any liquid as an electrolyte, it may leak out. As it is called dry cell, it is not completely dry. The paste or the electrolyte is used in the form of paste. It provides movement of electrons and it also cannot be leaked out as it is sealed, or the container used is sealed. Understood? So, this is the construction of the cell. Now, actually, what happens inside the cell so that it generates electricity? As you know, it is voltaic cell. That means chemical reaction takes place which generates electricity. For that, one anode is needed, that is zinc container. One cathode is needed, that is carbon rod. And one electrolyte is needed, that is the paste of NH4 cell and Zn cell. There is also one more paste used, paste of MnO2 and carbon black. Why it is there? We are going to learn all about that in today's session. So let us start with cell reactions. First we will see oxidation at anode. When the cell operates, the current is drawn from the cell and metallic zinc is oxidized to zinc. First the reaction is anode oxidation, which takes place at anode. What is anode? Here zinc is anode. Hence zinc will get oxidized to zinc ions. Oxidized to zinc ions. There should be a word ions. So Zn gives Zn plus 2 electrons. Understood? So metallic zinc is oxidized to zinc ions. As electrons are removed, it is oxidation. Now, these electrons are transferred to cathode where they are gained or they are absorbed, and the total reaction or the cell reaction gets completed. But some critical process is going out inside the cell, and the sequence of reactions take place at cathode. What are those? We will see one by one. I will give you reasons for every reaction. The electrons, so next we'll see the reduction at cathode, so that the electrons liberated in oxidation at anode flow along the container and migrate to cathode. At cathode, NH4 plus ions are reduced. So, what is electrolyte? It is a paste of NH4Cl and Zn cell. Out of that, NH4Cl, when it is in the form of paste, it will get converted into ions, that is NH4 plus Cl minus. Those NH4 plus ions at cathode accept those electrons and get reduced to ammonia. So the reaction will be like this. NH4 plus, as 2 electrons are released, hence I have balanced already the reaction. So I have taken 2 NH4 plus ions. Those will accept 2 electrons and will get converted to ammonia, aqueous, because the paste is there because of moisture. Ammonia is dissolved. So it is ammonia in aqueous form. Plus hydrogen gas. As hydrogen gas is produced, where it is accommodated then? Hence, that hydrogen gas should be treated so that it will not be released as the cell is sealed. Hence, hydrogen gas produced in reduction reaction is oxidized by MnO2 and prevents its collection on cathode, as it is in gaseous form. So its collection is avoided, and for that only the paste of MnO2 and carbon is used. And that MnO2 reacts with hydrogen gas and gives Mn2O3 plus H2O. Understood? So hydrogen gas liberated in the reduction process is treated, or it reacts with MnO2 and gets converted into Mn2O3 plus H2O. As H2 is produced, again the somewhat moisture is created, and which helps for movement of electrons. Hence, the cathode reaction will be the addition of these two reactions, because the reactions go on in a sequence. Hence, by adding these two reactions, the net cathode reaction is obtained. So, the net reduction reaction at cathode is combination of these two reactions. This will add left side to the left and right side to the right. So, what is left is twice NH4 plus 2 MnO2 plus 2 electrons. Hydrogen and hydrogen will be cancelled. Now it will give you Mn2O3 plus twice NH3 plus H2O. So hydrogen gas is nullified, or it is converted into H2O by MnO2. So this is net cathode reaction. We got net anode reaction. What is it? Zn gives Zn plus 2 plus 2 electrons. And this is cathode reaction. Then what is net cell reaction? Again, net cell reaction is the addition of anode and cathode reactions. So that Zn gives Zn plus 2 electrons, that only will be added in this. And while adding 2 electrons from left and right will be cancelled, and hence the net cell reaction is, as I had told you, sum of oxidation at anode and reduction at cathode. So to the left side we are going to add Zn plus 2, and to the right side we are going to, to the left side we are going to add Zn only, and to the right side we are going to add Zn plus 2. 2 electrons from cathode and 2 electrons for anode are cancelled, and hence the net cell reaction will be to the left Zn plus twice NH4 plus twice MnO2. Only this Zn is added to the net cathode reaction. And 2 electrons are cancelled, To the right side, Zn plus 2. Zn is converted to Zn plus 2 by releasing 2 electrons. So Zn plus 2 plus Mn2O3 plus twice NH3 plus H2. So the net cell reaction is the addition of anode reaction and cathode reaction. So this total reaction is like this. You have to remember or just practice the reactions because correct reaction is needed in exam. Single small mistake will give you 0 marks total. Hence, correct and accurate reactions are needed while writing the answer in exam. Understood? Now, the ammonia produced here, it combines with Zn plus 2 ions to form soluble compound containing complex ion. Further, as I told you, a chain of reactions take place here. Now, the Zn plus 2 and ammonia produced, they both will react with each other and they produce zinc Zn in bracket NH34 and total plus 2. That means it is a complex ion which is produced every time a reaction or total cell reaction or circuit of reactions gets completed. So this ion is the final reaction. In exam, a question like write construction and working of dry cell can be asked. At that time, you have to draw a figure, you have to describe it. So figure with correct labels will give you marks. Labels are needed, definitely needed. In cell reactions, as I told you, you have to give complete reactions. Oxidation at anode, what happens there? Reduction at cathode. At cathode, when hydrogen is produced, it is then treated with H2 to produce Mn2O3 and H2O. And again, net cathode reaction you have to write. And lastly, net cell reaction is the sum of oxidation and reduction. So this is all about the cell reactions. The last point of this is uses. Dry cell, as you know, it is used as a source of power in flashlights, in portable radios, in tape recorders, clocks, and so on. So, as you know, dry cell batteries, they are needed in our day-to-day life. We use it easily, but what actually dry cell is that we learn today. Understood? Just practice the reactions again and again to keep them in mind because as I told you, correct reaction is needed to get marks. This question might be asked for 3 marks. So that is the assignment for today. So assignment will be explain construction and working of dry cell. So draw the figure, proper figure, construction in which you have to give complete description. The main points checked in exam are what is anode that you should give, what is cathode, and what is electrolyte. Those 3 things are must. And again, the remaining things you have to give, but the marks are for there for anode, cathode, and electrolyte. Cell reactions, correct cell reactions. So 1 mark is for figure, correct labeled figure. Secondly, construction will give you 1 mark, and cell reactions will carry 1 mark. Understood? So this is all about today's session. Next time, we are going to learn about the secondary voltaic cell. Because the primary voltaic cell, only one is added in your syllabus, that is dry cell. And in secondary voltaic cells, we have to learn lead storage battery in the next session. And that is also a somewhat critical. Cell reactions are very critical because it is secondary voltaic cell. That means charging and discharging both take place, and hence the reactions you have to remember the number is more and those are critical as well. but we will learn it in the next session. So, this is for today. Thank you.